Welcome, space explorers. Today we dive into a question that has fascinated humans for centuries. How many stars are in the Milky Way? Our journey begins with the grandeur of our home galaxy, the Milky Way. An awe-inspiring spiral of stars, gas, dust, and dark matter, the Milky Way is a cosmic whirlpool where we find our humble abode, Earth. It's a barred spiral galaxy, a galaxy with a bar-shaped core region surrounded by a whirling disk of stars. Its significance? It's but a tiny speck in the vast universe. And yet it's a vast universe unto itself, filled with billions of stars and countless mysteries. But how many stars are there exactly? Now there's a question that's not as straightforward as it seems. The Milky Way is so vast and filled with so many stars that it's nearly impossible to pin down an exact number. Astronomers estimate there could be anywhere between 100 billion to 400 billion stars, each one a burning beacon in the cosmic sea. Yet this is no easy task. The vast distances, the variety of star types, and the confounding effects of dark matter make it a Herculean challenge to count the stars. Astronomers use techniques like long-slit spectroscopy and analyzing galaxy mass to make their estimations. The Gaia mission, for instance, has mapped 1.7 billion stars near the Sun, but even this is just a small fraction of the total. As we delve deeper into this topic, we'll explore the vastness of the Milky Way, the methods astronomers use to count the stars, the challenges they face, and what the future holds for this cosmic census. As we delve deeper, prepare for a journey of astronomical proportions. The Milky Way, our celestial home, is a barred spiral galaxy, a cosmic conglomeration of stars, gas, dust, and dark matter, a resplendent haven of light nestled in the infinite expanse of the universe. How many stars does this home of ours hold, you might wonder? The estimates are staggering, ranging from 100 to 400 billion stars. That's billion with a B, an almost incomprehensible number. To put that into perspective, let's consider this. If each star in the Milky Way were a grain of sand, they would fill up over 2,000 average-sized swimming pools. Imagine, each pool brimming with the twinkling grains, each representing a star, a potential solar system, a possible beacon of life. That's the enormity of our Milky Way. Or think about this. If you tried to count each star in the Milky Way at a rate of 1 per second, it would take you over 31,700 years to count them all. That's longer than the entire span of recorded human history, to count the stars in our single galaxy alone. Yet it's not just the numbers that amaze us, but the vast distances between each star. The average distance between stars in the Milky Way is about 5 light years. That's the distance light, the fastest thing in the universe, covers in 5 years. Imagine the enormity, the immense spaces, the sheer scale of our galaxy. These numbers, as mind-boggling as they may be, are only estimates. Our understanding of the universe is continually evolving, and with it, our estimates. The Milky Way is a stellar wilderness, teeming with a breathtaking array of celestial bodies, each one a mystery waiting to be unraveled. So we have a range, but how do astronomers arrive at these staggering numbers? Counting stars isn't as simple as counting apples in a basket. Astronomers use techniques like long-slit spectroscopy and analyzing galaxy mass. Now, you might wonder what on Earth, or rather, what in space, these methods mean. Well, let's break it down. First, we have long-slit spectroscopy. This technique sounds complicated, but it's easier to understand when we look at its parts. Spectroscopy is the study of how light interacts with matter, and the long-slit part refers to a narrow opening that astronomers use to focus on a specific part of a galaxy. By observing the light that comes through this slit, scientists can gather information about the speed, temperature, and chemical composition of stars. This provides them with a clearer picture of how many stars there might be in a given area. The second technique involves analyzing galaxy mass. You see, every star contributes to the overall mass of a galaxy. By measuring the mass of the Milky Way, astronomers can make an educated guess about the number of stars it contains. They do this by observing the motion of stars and gas within the galaxy. But of course, it's not as straightforward as it sounds. Stars aren't all the same size or mass. Some are as small as our own sun, while others are colossal giants. This means that the mass of the galaxy can only give us an estimate of the number of stars, not a precise count. These techniques provide important insights, helping astronomers come up with an estimate of between 100 billion to 400 billion stars in the Milky Way. But remember, this is still an estimate. These techniques provide an estimate, but what about the stars that are hard to see? You see, not all stars are easy to spot. Some are faint, some are obscured by dust and gas, and some are simply too far away to observe clearly. So how do we count these elusive stars? Well, that's a challenge for another scene. Not all stars shine brightly. Some are faint, and others are hidden as double stars. These present a real challenge in our celestial senses. Imagine you're in a pitch-black room trying to count the number of dust particles floating in the air. Difficult, isn't it? That's somewhat similar to the challenge astronomers face when trying to count faint stars. These stars, often located in the farthest reaches of the Milky Way, emit such a weak light that they can be extremely difficult to detect. The fainter the star, the harder it is for our telescopes to spot them against the vast darkness of space. Now, let's talk about double stars. These are pairs of stars that orbit around a common center of mass, and they can be tricky little devils. Why? Well, from our vantage point here on Earth, these double stars can appear as a single point of light. So, when astronomers are counting stars, they might count a double star as just one star, when in fact there are two. These factors, faint stars and double stars, contribute to a wide range of possible star counts. It's not as simple as pointing a telescope at the sky and tallying up what you see. There's a lot of detective work involved. Astronomers have to use complex techniques and calculations to estimate the number of stars. They have to account for the light they can see, the light they can't, and the light that's coming from not just one, but potentially two stars. But here's the beautiful part. Despite these challenges, astronomers are not deterred. They're continually mapping the stars, pushing the boundaries of our knowledge. Every day, we inch closer to a more accurate count, and with each star we catalog, we learn more about our galaxy and our place within it. Despite these challenges, astronomers are continually mapping the stars, pushing the boundaries of our knowledge. The Gaia mission, an ambitious project by the European Space Agency, has already mapped 1.7 billion stars near the Sun. A staggering achievement, no doubt, but it's only the beginning of the journey. Gaia's goal is far-reaching and audacious, to provide a comprehensive three-dimensional map of our galaxy, detailing the position, distance, and movement of the stars. Imagine the enormity of this undertaking. Gaia, a solitary spacecraft in the vast expanse of space, tirelessly cataloging billions of celestial bodies. It's a testament to human ingenuity and our relentless quest for knowledge. Now, the year 2025 holds particular significance for Gaia, and indeed for our understanding of the Milky Way. Astronomers anticipate that by then, Gaia would have gathered enough data to refine our estimates of the number of stars in our galaxy. However, it's important to remember that even with Gaia's data, we may still not have a definitive number. Counting stars is a complex task, fraught with challenges. Faint stars, double stars, and regions obscured by dust and dark matter continue to elude precise enumeration. But these challenges do not deter us. If anything, they fuel our curiosity and drive us to innovate. With every passing year, our techniques become more sophisticated, our tools more precise, and our understanding of the universe deeper. So, the quest to count the stars continues, promising exciting discoveries in the years to come. Our journey today brings us to a humbling realization of our place in the universe. We've explored the staggering number of stars in the Milky Way, estimated between 100 to 400 billion. We've delved into the intricate methods used to count these celestial bodies, from long-slit spectroscopy to analyzing galaxy mass. We've also glimpsed into the future of star counting, with the Gaia mission promising to reveal more mysteries of our galaxy. We hope you enjoyed this cosmic journey. Please subscribe for more videos and join us as we continue to explore the mysteries of the universe.